introduce us to Nifflas. I'm so glad we've got. I've got a little bit of echo.
Oh yeah, I need to disable the stream volume somehow. How do I do that?
Yes. Right click on the tab, mute.
On the what?
Right click on the tab and mute. I think we're good.
Oh, okay.
Okay. All right. Well, I will let you take it away, Nifflas. Thank you.
Right. Hey, my name is Nifflas, and I made my own algorithmic music software. I'm also making a game about my dog. This is Hot Dog. She's a very good dog. And I'm making a game about her that looks like this. You control the dog, and the dog can compose music using this drum machine interface, like this. And yeah, you can see the level reacting to the music now. And now I have to complete the challenge with the music I just composed. I noticed that all the music kind of changes in intensity as I proceed in this level now. Now that I'm reaching the end of this challenge, the music starts getting calm again. And that's kind of how my game sounds. But now I want to show the software where I make this music, which is over here. So I'm gonna start with showing the step sequencer algorithm. This is the most normal algorithm you will see in the software. Basically, it's a step sequencer. It plays drums from the top to the bottom. Every time it collides with one of these squares, you hear a sound. Sounds like this. But as you can see, this cursor that's actually playing the sounds is jumping it's jumping around a little bit randomly. And that's because there's an expression here that says chance 0.5 that it will take 3 cursors above or below. So I can do this. Let's grab a knob, for example, and connect the knob to the step sequencer and just plug the knob in here instead. And now I have a knob that where I can control the chaos in this cursor. So at 0 it's no chaos at all, but at 1 we have like full jumping around like crazy. Yeah. And what's neat about that is that if I create a group here and name it something like fish, now I have the name fish here. I can reference this in my game itself, and now the game can control this aspect of the music. Next instrument I want to show is the rainbow/arpeggiator. So what this is, it's an arpeggiator. It's on the synthesizers you will often have like you play a number of notes at the same time, but instead of actually hearing all the notes at the same time, the arpeggiator is a module that alternates automatically between the notes. A Commodore 64 usually does that to preserve the number of sounds it can play at the same time. But this is a common synthesizer feature. Sounds like this. You can see the pattern here going up. But what's interesting about the Rainbow device is that this can do real-time sorting, one at a time on this array. So soon it's going to start sorting this in reverse. And it's you're going to see it in real time and also hear it. Yeah, it's starting now. And now we have a reverse array. And that's, yeah, it's I sometimes use that device, for example, when I have a melody that's playing on repeat, but every time you walk through a door, you end up with a slightly changed variation of that melody, and things like that, things that just manipulate the music as you go by doing this weird sorting thing is. Next up, I want to show the Desire device. This is a device that plays, it has 5 different triggers, like notes that it wants to play. There's like this bar, you're gonna see it when I start, that just this bar starts going in this direction. And the bigger one of these bars are, the stronger the desire is to trigger that note. And that's a nice way to control that. You get more controlled randomness, where things that hasn't happened for a while are more likely to happen over time. But also, it's another aspect of it is that I can control when these desires are active and build up and when they don't. It sounds like this. So you have like these periods when it starts playing more notes, and then you have other periods when it's not playing many notes at all, and it kind of goes back and forth between those. And then I should show the reflector. This is one of my most bonkers looking devices. What this device does is that it spawns 2 cursors in here that just bounces around. So a cursor travels in one direction until it collides with something and then swaps direction. When it collides with a white square, it always reflects, but when it collides with one of the colors in between, there's a chance that it will reflect and a chance that it will proceed in the same direction. And this means this pattern, I kind of just improvised by this pattern by listening and putting squares until I had the precise kind of behavior I wanted, where these cursors bounce around a bit and make a lot of sounds. Then they exit, make very little sound for a while, but then gets reflected back in and starts making lots of sounds again. This one sounds like this. So that's how the percussion works in the song. I have some more percussion also in the railway device. This device, I made this when I was gonna go on a train trip. And this is based on the step sequencer, but it has a different behavior. So I say, I would put it like there are 3 railway tracks here. So we have, yeah, 1 second. Track number 1 is here, 2 is here, 3 is here, and 4 is here. And you have like this cursor that starts to travel downwards and playing notes. But for every note that it plays, there's also a chance that it will jump to the next track. So you kind of get this thing where you get more variation by the train just changing tracks. And this one sounds like this. Oh, 1 second. So now you can see the cursor traveling down and changing tracks. So yeah, that's the railway device. Then I want to show the democracy. Oh, gotta clear that. I'm not used to my new shortcuts. This is a little drum sort of weird thing that I made. The way I made this was I asked on... oh, 1 second. I asked on Twitter. This was back when before Twitter was really terrible. It's like, let's compose a drum loop together, and people got to vote for what goes into the different steps of the drum loop. And then I combined all the different weights into these arrays. So these are like all the average results from these different poll results. And back in the music software, it sounds like this. With these specific weights that you see over here, this is the drum beat we get out of it. And there's a second device I want to talk about connected to this instrument, which is also inspired by trains, which is the train stop device, which are these two things here. The way they work is that you have a railroad, and here you have a station. Every time the democratic beat device wants to play a note, it decides to send off a little train, and the train carries the note information. And then when I was stuck in train traffic when I wrote this algorithm, and I didn't know because I was 3 hours and nothing was happening because a whole series of trains was stuck because some accident thingy. And so I wrote this algorithm that lets me put up a stop. And now none of the trains are allowed to reach the station, and they start queuing up more and more of them. And then suddenly the trains are allowed to go again. And now the trains has a lot of catching up to do, so now they start going like super, super fast. And that's how I took a real-life situation and just turned it into this algorithm. So if I activate the train stop now, and re-enable them. So you get this kind of weird fills. And next up, the tweet randomizer. This is a very chaotic device. 1 second. Wait. Oh, wrong button. I just added shortcuts to the software and I haven't learned them yet. So the story behind the tweet randomizer is I needed random values, and the fact is random values aren't that random. Even computer generated random values, like look at this for example. This is a sequence of random numbers that I just got from the internet. Got some website to generate them for me. Like you can't really go like, look at the 61, that's so random. No, the 61 isn't random at all. Like this, none of this looks random. It's just numbers, and they are super evenly distributed, and it looks like white noise. It's no, so I wanted to have real random numbers. So I tapped into the most random thing there is, which is the human mind. I asked on Twitter, again, back when Twitter was not horrible, please give me sequences of random numbers that you can come up with in your head. And look at this. So here we have 7, 7, 7, 7, 7, 7, and 4. Like, that is random. That is extremely random. We have this sequence, 9, 100, and then there's suddenly like this absolutely massive number. This sequence has a negative number. There's just one of them, I believe, in all these different sequences. One negative number. That is completely random. And I use it to drive this instrument that sounds like this. But then I can try a different, somebody else's random sequence instead, and I get a completely different result. So now you get something that kind of sticks more to the same notes. And that is because this specific note sequence I just played is based on this instead, which is 0, 1, 0, 1, 0, 1, 0, 1, and then a bit later some other values comes up. And then I want to talk about the Monte Hall problem. So the Monte Hall problem is a very classic problem, a logic kind of statistics problem. In case you haven't heard of it, it works like this. There are 3 doors. 1, 2, and 3. There's you, and there's a host, which is Monte. Behind these doors, there are 2 goats and 1 car, but you don't know which door has the car. But say you pick door number 1. Then Monte goes and opens door number 2, and this door has a goat in it. And you get to choose, should you stick to door number 1, or should you change your choice to door number 3? And it sounds like it should be a 50-50% chance, but you actually double your chances if you switch to the other door. Or that would be the case under the standard assumptions, but why would you make the standard assumptions, right? There's a few questions here. Like, is the host evil? Does the host actually know which door has the car? Does the host think that the player knows the Monte Hall problem? Is the host in a hurry? Does the host have to open another door? And can the host open another door intentionally, or can they just... Well, yeah, can they open the car door intentionally and just show the car and let the player switch to it? And does the host have to offer to switch? And yeah, for example, under the standard assumptions, we can get this melody. This is based on 14 iterations of this particular configuration. But let's randomly change around, and we get a completely different melody because the outcome becomes completely different of the problem. We change it some more. And you might ask, why use the Monte Hall problem to compose algorithmic music? And I think it's best if I show you in the game the reason. I'm not sure it's a good reason, but it's definitely a reason. Let's see here. Put some volume back, and let's teleport over there. Just gonna give myself some money also. So you meet another dog. The picture of the dog is placeholder. And now you choose the door. And well, then I choose the left door. Ah, it's also a goat. But I'll try again. And the funny thing is, when the car's position is randomized, the algorithm you hear playing the music is the Monte Hall problem itself. And why exactly did I do this? The best answer is why not, right? But let's see here. I think I might have been a little bit faster than I intended. But now I want to do a performance of music using my adaptive music software. So I'll just put together the different algorithms I showed and other algorithms too. And you can hear what it sounds like. And a thing is that every control I will press or change is also a control that the game has the possibility to modify. Yeah. so that's what my music software can do when you change all the parameters. And I think I should end with I should tell you that for the first time the game now has a Steam page, so it would be super nice if you would want to wishlist it. And this nice key art is by an artist named One Naila One, who I want to credit, and has the art links here. And I think that's what I had.
Amazing. Thank you so much for giving us a nice demo at the end here too. We got a live roguelike celebration set. It reminds me of people playing modular synths, but actually know what they're doing. There's a little more structure there where I can parse what you're doing to some degree.
Yeah, it's a little bit different because modular synths is basically, it's mostly audio signals, but my modular software is for making musical decisions instead.
Yes, exactly. And that's why I feel it feels so much more parsable to especially a layperson. Gosh, that was so cool. We had so many great comments the entire video, and definitely going to be checking it out again and sending to a bunch of people that I know will love it. We got a bunch of questions here. I think we have time for maybe one or two. We saw the sort of like automata, like symbols sort of playing music, but Too Much Abstraction asked, do you have any director systems that try to manage tension or intensity over the course of longer time periods?
That's actually, that part is built into the level rather than built into the music software. So a lot of that is I placed a lot of different zones all over the level in my level editor. So as soon as you progress in any way, you pretty much enter a new stage of the music. There are even variations. Just when you can run over a platform, for example, I might increase the intensity of the music while you're on top of that platform running.
Sure. Yeah, it makes sense that there's some of the dynamicness of the editor allows you to have gameplay elements that sort of reflect what's happening in the music as well. So something that I'm curious, and also one of the top rated questions here, do you plan to make that tool available after the game is out? Tyreek mentioned it looks like an absolute joy to work with.
It's incredibly difficult to use. I don't have the skill in myself. I want to, but I would need funding, and I would need to work together with someone who is really good at actually making this software easy to understand for someone who isn't me.
Sure. Yeah. I mean, I feel like we have a lot of tinkerers that don't necessarily need documentation. They'll just start clicking things until they figure it out. But it makes sense to, like, when you release something, you want it to be like usable.
Yeah. The tricky thing is it's mostly done through expressions. Even though you have like this interface with connecting things, most of the thing you do is writing expressions, and the expressions aren't documented, so you don't actually know what they are unless you know the software inside out. So at least I would have to document it somehow.
Yeah, right. Yeah, I was also reminded of these Instagram videos I've been served recently of this woman who's doing like live coding. There's like it's like you're literally writing code, but it does some auto completion and stuff, and just has like loops built into each block that you build. But I think the visual interface and being able to interlink things like that is really, really powerful. And I hope everyone goes out and wishlist Rhythm Doggo. I know I will be. And Nifflas, thank you so much for presenting here. We really enjoyed it.
Thank you for having me.